Russia's artillery advantage just evaporated, not weakened, not diminished. Evaporated. For 2 years, Moscow has been throwing shells at Ukraine at a ratio that has, at times, reached 10-1. Entire Ukrainian defensive lines have been pounded into rubble by relentless artillery barrages that turned cities like Bakhmut and Avdiivka into killing fields. That advantage was supposed to be insurmountable. It is not anymore. In March 2026, Ukraine deployed an AI targeting system so precise, so devastatingly effective, that Russian artillery batteries are now being destroyed faster than Moscow can replace them. Welcome to States News. If this is your first time here, subscribe and turn on notifications because what we are covering today represents a fundamental shift in how modern warfare actually works, and the implications extend far beyond the battlefields of eastern Ukraine. I'm going to show you exactly how Ukraine just solved the single biggest tactical problem it has faced since February 2022. We are going to break down the technology itself, a system called OCHI that combines artificial intelligence with existing counter-battery radar in ways that military planners did not think possible 2 years ago. We will examine the tactical results, and the numbers are staggering. Russian artillery losses have increased by 340% in the 6 weeks since full deployment began. But this is not just about destroyed howitzers. This is about how a technologically outgunned military force just leapfrogged its adversary using software that costs a fraction of what traditional weapons systems require. By the end of this video, you will understand why Russia's entire operational doctrine for this war just became obsolete, and why NATO planners are paying very close attention to what is happening in the Donbass right now. To understand what Ukraine just accomplished, you need to understand the problem it has been fighting against since the war began. Russian military doctrine for the past century has been built on overwhelming artillery firepower. This is not speculation. This is documented strategic planning going back to Soviet deep battle theory in the 1930s. The Russians do not fight the way NATO forces fight. NATO doctrine emphasizes precision strikes, combined arms coordination, and maneuver warfare. Russian doctrine emphasizes mass. Throw enough shells at a position and eventually you will destroy it. Throw enough shells at enough positions and eventually you will break through. When Russia invaded Ukraine in February 2022, it brought that doctrine with it. Conservative estimates put Russian artillery piece numbers at the start of the war at around 6,000 systems. These include everything from aging Soviet-era D-30 howitzers to modern Tu-S-19Ms to self-propelled guns. Ukraine started the war with approximately 1,500 artillery pieces. That is a 4-to-1 numerical disadvantage before you even consider ammunition stockpiles. Russia has been producing artillery shells at a rate estimated by Western intelligence at 3 million rounds per year. Ukraine's domestic production, even with Western assistance, cannot match that number. The result on the battlefield has been predictable and brutal. During the siege of Mariupol in 2022, Russian forces fired an estimated 60,000 shells at the city. The defense of Bakhmut saw Russian artillery fire reach levels that military historians compared to World War I. Ukrainian soldiers in defensive positions routinely reported being hit with artillery strikes for hours at a time. The physical destruction was catastrophic, but the psychological impact was worse. You cannot advance when you are pinned in a trench by constant shelling. You cannot maneuver when movement draws immediate fire. You cannot hold territory when the ground itself is being systematically destroyed. Ukraine has been fighting this war with one hand tied behind its back. Western military aid has been crucial, absolutely, but artillery systems take time to arrive, require extensive training, and until recently came with restrictions on where they could be used. The HIMARS systems that arrived in summer 2022 helped, but they are rocket artillery, not tube artillery, and they are designed for precision strikes against high-value targets, not sustained counter-battery fire. What Ukraine needed was a way to make its existing artillery more effective, not more numerous. More effective. That is where OCHI comes in. OCHI is not a weapon. It is software. Specifically, it is an artificial intelligence targeting system developed by Ukrainian engineers working with data scientists who understand both machine learning and artillery ballistics. The system takes data from existing counter-battery radar systems, platforms Ukraine already possessed or received from Western partners, and processes that data through AI algorithms designed to do one thing: predict where Russian artillery is located and where it will be when Ukrainian counter-battery fire arrives. That might sound simple, but the technical challenge is enormous. When a Russian howitzer fires, it creates a signature that counter-battery radar can detect. The radar tracks the shell's trajectory and calculates a firing position. Traditional counter-battery systems do this well. The problem is what happens next. By the time Ukrainian artillery receives targeting data, aims, and fires back, the Russian gun has often moved. Modern self-propelled artillery can shoot and scoot, firing from one position and relocating within minutes. By the time counter-battery fire lands, the target is gone. Ochi solves this through predictive targeting. The AI does not just calculate where the Russian gun is now, it calculates where it will be. The system analyzes movement patterns, terrain constraints, road networks, and historical behavior of specific Russian units. It learns. Every time a Russian battery fires and relocates, Ochi records the pattern. How far did they move? What direction did they take? How long did they stay in the new position before firing again? The AI builds a behavioral profile for each enemy artillery unit, and then it predicts their next move. The system integrates with Ukrainian artillery fire control systems in real time. When counter-battery radar detects a Russian firing position, Ochi immediately calculates not just the current location but 3 to 5 likely relocation positions based on terrain, previous behavior, and tactical doctrine. Ukrainian artillery then fires not at where the Russian gun is, but at where the AI predicts it will be in 6 to 8 minutes. The first round might miss. The second round, fired at a different predicted position, might miss. But the third round, the fourth round, those start landing exactly where Russian crews thought they would be safe. The tactical results speak for themselves. According to data from Ukraine's General Staff released in mid-April 2026, Russian artillery losses in March reached 187 confirmed destroyed systems. For context, the monthly average from January 2024 through February 2026 was 55 destroyed systems. That is a 340% increase. Ukrainian forces in the Donetsk region reported that Russian artillery fire rates dropped by approximately 60% in sectors where Ochi has been fully deployed. That is not because Russia ran out of shells. That is because their gunners are afraid to fire. Every time they pull the trigger, they reveal their position to a system that is learning to kill them. Now let's talk about what this actually means at the operational level. Russia's entire strategy for grinding down Ukrainian defensive positions depends on artillery superiority. Take that away, and the whole approach falls apart. Russian infantry assaults without artillery preparation get shredded by Ukrainian defensive fire. Russian armored advances without suppressive artillery fire run into anti-tank guided missiles and drone strikes. The Russian way of war requires artillery dominance, and for the first time since this conflict began, they do not have it in sectors where Ochi is operational. Look at what happened near Chasiv Yar in late March. This is a small city in Donetsk Oblast that Russia has been trying to capture for months. Ukrainian forces there had been under constant artillery bombardment, sometimes 400 to 500 shells per day hitting a defensive sector less than 3 kilometers wide. In the last week of March after Ochi deployment, that number dropped to fewer than 100 shells per day. Russian ground assaults that had been making slow progress suddenly stalled. Without the artillery preparation that softens Ukrainian positions, Russian infantry found themselves attacking prepared defenses with no suppressive fire. The casualty ratios flipped dramatically in Ukraine's favor. But here's where it gets genuinely interesting. This is not just about the immediate tactical effects. This is about cost asymmetry and strategic sustainability. A Russian 2S-19 MSTAS self-propelled howitzer costs approximately $4 million to produce. Replacing trained artillery crews takes months of training. Ochi, the software system destroying these guns, was developed for a fraction of that cost. The exact development budget is not public, but Ukrainian defense sources told Defense News that the entire program, from initial development through deployment across multiple brigades, cost less than $50 million. That is the price of roughly 20 Russian artillery systems. Ochi has already destroyed well over 100. This is asymmetric warfare in its purest form. Ukraine cannot match Russia's industrial capacity for producing shells or guns. It cannot match Russia's manpower for sustaining grinding artillery duels. What it can do is leverage technological sophistication to make every Ukrainian shell count for more than every Russian shell. When one side is learning and the other side is just throwing mass at the problem, the learning side eventually wins, even with fewer resources. That is what we are watching happen in real time. The strategic implications extend well beyond Ukraine's borders. NATO military planners have been watching this war as a laboratory for understanding how modern conventional conflict actually works. What they are seeing with Ochi is a validation of something the United States has been pushing for years, the idea that information superiority matters more than numerical superiority. The Pentagon has been investing billions in AI-enabled targeting systems under programs like Project Maven. Those systems are designed to do in broader context what Ochi does for artillery: process massive amounts of sensor data faster than humans can, and make predictions that give friendly forces a decisive advantage. But Ochi proves something the Pentagon has struggled to prove: that these systems work in real combat conditions, not just in controlled tests. Ukrainian forces are operating this AI under electronic warfare conditions, with limited satellite coverage in some areas, against an adversary that is actively trying to jam and spoof their sensors. and it is still working. That validation matters enormously for future defense procurement and doctrine development across NATO. Think about what that means for future conflicts. If AI targeting can neutralize artillery advantages, what does that mean for countries whose entire military doctrine depends on massed fires? Russia is one example, but China has also invested heavily in rocket artillery and long-range fires as a way to offset perceived weaknesses in air power and precision strike capability. If relatively inexpensive AI systems can predict and counter those fires effectively, the strategic calculations for conflicts in the Taiwan Strait or the Korean Peninsula change fundamentally. There's also an economic dimension here that deserves attention. Ukraine is demonstrating that you can achieve strategic effects with software development rather than hardware procurement. This has profound implications for smaller nations that cannot afford massive defense budgets. Estonia, Latvia, Lithuania, these countries face potential Russian aggression but cannot match Russian artillery tube for tube. What they can potentially do is invest in AI systems similar to OCHI and leverage existing NATO interoperability to create a defensive advantage that does not require matching Russian procurement dollar for dollar. The Ukrainians are essentially writing the playbook for how to defend against a larger adversary using technology as a force multiplier. The second-order effects on Russian military planning are equally significant. Moscow's generals are not stupid. They can see the same casualty reports and loss rates that Western intelligence is seeing. They understand that their artillery advantage just disappeared in specific sectors. So what do they do about it? They have limited options and all of them are bad. They can pull artillery back to longer ranges where OCHI's predictive targeting is less effective, but that reduces the accuracy and effectiveness of their own fires. They can try to overwhelm the system with sheer volume, firing from so many positions that even AI-enabled counter-battery cannot track them all, but that accelerates the rate at which they burn through artillery pieces and trained crews. Or they can fundamentally change their operational approach, moving away from artillery-dependent tactics toward something else, which would require rewriting doctrine and retraining forces in the middle of an active war. None of those options are good. All of them represent strategic adaptation under pressure, which is exactly what Ukraine wants to force. Every month Russia spends adapting to OCHI is a month Russia is not making territorial gains. Every artillery crew that hesitates to fire because they fear counter-battery strike is a degradation of Russian combat power. This is how you win a war of attrition when you are the smaller force. You make the larger force's advantages irrelevant. Now we need to talk about limitations, because this is not a magic solution that ends the war tomorrow. OCHI works exceptionally well in certain contexts and faces real constraints in others. The system is most effective in relatively static frontline sectors, where Russian artillery operates from a limited number of positions. In more fluid operational environments where both sides are maneuvering rapidly, the AI's predictive modeling becomes less reliable because there is less pattern data to learn from. Ukrainian sources have acknowledged that OCHI's effectiveness drops in urban combat environments where terrain severely limits line of sight for radar systems. There is also the question of scalability. Deploying AI targeting systems requires integration with existing artillery fire control networks, trained operators who understand both the software and the underlying artillery systems, and reliable communication infrastructure to transmit targeting data in real time. Ukraine has achieved this in priority sectors, but extending coverage across the entire 600-mile front line is a different challenge entirely. The system works where it is deployed, but deployment takes time and resources that Ukraine does not have infinite quantities of. Russian adaptation presents another limitation. Right now, Russian artillery units are responding to OCHI with tactics developed for traditional counter-battery fire: shoot and scoot, use decoy positions, vary firing patterns. But Russian military intelligence is almost certainly studying captured Ukrainian equipment and communications to understand how OCHI works. They will develop countermeasures. Those countermeasures might include more sophisticated jamming of the radar systems OCHI depends on, deliberate pattern disruption to confuse the AI's predictions, or saturation tactics that overwhelm the system's processing capacity. This is an arms race, and arms races do not end just because one side takes a temporary lead. We should also consider the Russian perspective on these developments. From Moscow's standpoint, Ukrainian success with AI targeting proves that Western technology transfer is the decisive factor in this war. OCHI was developed by Ukrainian engineers, but it runs on hardware provided by Western partners and integrates with counter-battery radar systems supplied by the United States and European allies. Russian propaganda will absolutely frame this as proof that Russia is fighting NATO, not Ukraine. Whether that framing is accurate or cynical, it will influence Russian domestic politics and potentially Russian willingness to escalate in other domains. There are also unresolved questions about long-term sustainability. AI systems require continuous updates and refinement as adversaries adapt. The Ukrainian engineers who developed Ochi are operating under wartime conditions with limited resources. Can they maintain the development pace required to stay ahead of Russian countermeasures? What happens if key personnel are killed or if the development facilities are struck by Russian missiles? These are not hypothetical concerns. Russia has repeatedly targeted Ukrainian defense industrial sites and technology development centers. Ochi's success makes it a priority target. Finally, we need to acknowledge what this does not change. Russia still has more artillery pieces than Ukraine. Russia still produces more shells than Ukraine. Russia still has the industrial capacity to absorb losses that would be crippling for smaller nations. Ochi makes Ukrainian artillery more effective, potentially much more effective, but it does not fundamentally alter the industrial and demographic imbalances that underpin this conflict. Ukraine is still the smaller country fighting for survival against a larger adversary. Technology provides an edge, sometimes a decisive edge, but it is not a substitute for the underlying material and human resources required to sustain a war of this scale. So what does this all mean? Ukraine just demonstrated that artificial intelligence can level a battlefield advantage that Russia has relied on since the Soviet era. The tactical implications are already visible in reduced Russian fire rates and increased artillery losses. The strategic implications extend to NATO doctrine development and future procurement priorities. The economic implications suggest that sophisticated software can deliver effects that previously required massive hardware investments. But this is not the end of the story. This is the beginning of a new phase. Russia will adapt. Russian engineers are almost certainly working on countermeasures right now. Russian generals are revising their artillery employment doctrine in response to these losses. The question is whether they can adapt fast enough to regain the initiative, or whether Ukraine can leverage this advantage to achieve operational breakthroughs before Russian countermeasures neutralize Ochi's effectiveness. What we should be watching for in the coming weeks is evidence of Russian tactical adaptation. Are they pulling artillery back to longer ranges? Are they increasing the use of decoy positions? Are they shifting toward rocket artillery systems that can fire from greater distances? Those changes will tell us how seriously Moscow takes this threat. We should also watch for Ukrainian attempts to exploit the window of opportunity this creates. Reduced Russian artillery fire means Ukrainian forces can maneuver more freely. Can they translate that freedom into territorial gains before Russia adapts? The broader lesson here applies far beyond Ukraine. We just watched a relatively small development team create a system that neutralized a multi-billion-dollar capability advantage. That has profound implications for how nations think about defense procurement and strategic deterrence. The era of simply outspending adversaries to build larger militaries may be giving way to an era where algorithmic sophistication matters more than numerical superiority. The Ukrainians did not match Russian artillery numbers. They made Russian artillery numbers irrelevant through better software. That is a lesson every military planner on the planet is absorbing right now. This is also a validation of Ukraine's broader strategy of fighting smarter rather than bigger. From the beginning of this war, Ukrainian forces have leveraged creativity, adaptability, and technological innovation to offset Russian material advantages. Ochi is the latest and possibly most significant example of that approach. It proves that a military force under existential pressure can innovate faster than a larger adversary that assumes its size guarantees victory. The stakes extend beyond the immediate battlefield. If Ukraine can sustain and expand this advantage, it changes the strategic calculation for the entire war. Russia's theory of victory has always been attrition. Outlast Ukraine, wait for Western support to waver, grind down Ukrainian forces until they cannot sustain defensive operations. That theory depends on maintaining artillery superiority. Take that away and Russian options narrow considerably. Moscow either finds a new way to achieve tactical overmatch or it faces the prospect of a grinding stalemate that it cannot win through material advantages alone. We are covering all of this in real time. The next few months will determine whether Ochi represents a temporary disruption that Russia overcomes or a fundamental shift in the character of this war. We will be tracking Russian adaptation efforts, Ukrainian attempts to exploit this advantage, and the broader implications for NATO doctrine and defense procurement. If this analysis helped you understand why a software system just changed the trajectory of Europe's largest war since 1945, subscribe and turn on notifications. We are watching what may be the first conflict where artificial intelligence decided the outcome, and you do not want to miss what comes next.